Really excited to be here. Really excited to be at this event. I was impressed with the opening. So like usually, if there is a DEI panel, it's like at the end of the day, like competing with a happy hour. So I think the fact that they start with that was really impressive, and to show that it's important. So thanks for the organizers for that. Going to be talking about a cloud of lies. So going to get into more of the challenges and more failures in cloud and what I've seen and experienced. And want to start a bit with my own journey to the cloud, to loving the cloud, and how the cloud broke my heart. So my first job in tech was actually writing software for the Canadian Navy, and specifically for these. This is the Halifax class frigate. There are 12 of them in the Navy, and it was super interesting out of university to write software for these things. Essentially, it was the brains of the ship. So everything that connected all of the radar systems, all of the weapon system, all of the sensors. So it was a really interesting problem space, the things that we had to solve. It was very challenging, very, very important, like literally life and death. And you might be able to tell from the diagram, also my age, the technology was not the most advanced. Like it was very, very old technology. So you see here it talks about 28 tactical computers, which were these. These were built, I think, in the 70s. They had a whopping like 64K of memory. It was a challenge, right? And we had to be really efficient with what we were writing in terms of software. And there wasn't really, auto-scaling wasn't a thing. I think it took like 6 to 12 months to provision one of these, and like you can't just fly them out to the ship when we need one. So we didn't really have a cloud. There was no network connection whatsoever. But we did, we needed business continuity. There was like real requirements where, okay, so a torpedo hits the side of the ship and like takes out half the computers. We still need to run the critical systems. So it was very challenging, but very interesting, in a very kind of different world. And then after that, I moved to a startup, building a SaaS-based platform, and we were entirely on AWS. And this kind of changed my world. It kind of opened me up to the cloud and what was possible, that I don't have to wait 12 months to get a new machine. I can just use the command line and spin up a new VM immediately in EC2, and it's the same as production. So this was kind of a revelation to me, and really started me on my transition from developer into the DevOps and cloud native world. And it's been amazing to see in the last 10 plus years the growth and the new services and the infrastructure as code and containers and Kubernetes and all these things grow. But I feel like in the past year or two, I've seen a lot more challenges, frustrations, failures. And most of that time I've worked as a consultant. So I work with companies who are adopting cloud, who are migrating to Kubernetes, who are trying to become cloud native. And I've seen a lot more challenges, I feel like, in the past year or two. And I'm not sure if that's kind of the state of the market where everybody's in cloud now, so necessarily there's more issues, more challenges. Or maybe we've kind of hit some limits, right? And this infinite computer that we have, that is the cloud, maybe we've discovered there's some limits to it. Or maybe it's just that, hey, I'm getting old. I've been here around for a long time, and this is what happens. You get jaded and start to yell at things. So, I'm not sure what it is, but it does seem to be a bit of a wider trend. And I noticed, actually, I think just after this talk, there's a lightning talk about the idea of on-premise coming back. This was a fairly recent survey from Barclays. They talked to a lot of CIOs, and specifically a question around repatriation. So companies who are planning to actually bring workloads back from the cloud to on-premise. And that's, so towards the end there, right, like first half 24, 83% are planning to bring things back from the cloud. So I think that shows a lot about the state of things, and maybe it's frustrations or disillusionment. And so I want to talk through some of the specific promises that the cloud made and how maybe they didn't live up to expectations, and run through a few examples of where I've seen that. The first one is kind of the core of cloud. And the first one is kind of the core of cloud, right? The whole idea of on-demand resources. That, again, I can just, when I need it, where I need it, spin up a new VM, spin up a new storage, spin up a new service, and it's available to me immediately in any region. I mean, this was the basis of the cloud, right? This is why Amazon launched AWS and EC2 to be able to offer these services on demand. You don't have to go and, rack and stack your own servers. You don't need your own data center. This was the start of cloud, and this is why we've had so much innovation in the past 10 years, right? If I'm a startup or have an idea for a startup, I don't have to worry about hardware. I don't have to go, put a bunch of servers in a server closet somewhere and rack them up and you pay for that all expense. I just sign up for an account with Amazon or Google or Microsoft and probably get a bunch of free credits, and I can prove out my startup idea, right? This is what's enabled so much innovation and change in the cloud, which is still very much the case in a lot of situations, unless you need GPUs. So I'm not sure how many people are familiar with kind of the state of where we're at with GPUs. I think started a lot by the kind of crypto space, but AI is definitely feeding into it very much, where these things can be challenging to get, right? And the rate of change within the industry as well, there's always next ones that come out which are miles better, 10x better, and that's what everybody wants. So turns out it's a bit challenging. And I'm actually working right now with a startup called Psalms AI. They're doing really, really amazing things in the generative AI space, actually for generating music. And they've got very cool patented technology. They've got clients lined up who want to give them money for this. And essentially they just needed some GPUs, some high-powered GPUs, to train their models and run inferencing. And so we were working with them, and we're like, okay, well, we'll go to the normal cloud providers, because again, they're a startup. They're not sure, what usage is going to look like, right? Maybe we need a couple GPUs today. Maybe we need 20 next week, and maybe we don't need them for a while. So again, this is the cloud model. So we tried that, and whether it's through console or whether through command line, and trying to get access to any high-powered GPUs on any of those clouds was just not possible. Basically just came up, just not available, no information. And we had to go and actually talk to them, talking to salespeople, which makes me hurt a little bit. Even had to talk to Oracle. And they all kind of came back with a similar answer, like, yeah, sure, we can get you some A100s. It's going to be like a 60-day lead time. Oh, and we need to sign up for this three-year contract, which is the opposite of the cloud model, right? This is crazy. One that I have to wait 2 months to get access to the hardware, and then you need to get locked into 3 years. Like this is not what we signed up for. And again, as a startup, how are you supposed to build around that model? The idea is that you want to be agile, that you need to adjust for your needs from the business, from users. So having to predict what you're going to need kind of 3 years down the line is crazy. So this is definitely a case where the core promise of cloud kind of falls through. And I've seen more instances of this, not just related to GPUs, where it's maybe certain instance types or certain services just aren't available, maybe in certain regions or for certain times. And it feels like this promise is starting to fall apart a bit. And the next one is maybe a bit more debatable, but I think is really central, right? The idea of the cloud being secure. And this is something that, again, as a consultant, I've spent years and years convincing people who are maybe a little bit scared to begin with about the security of the cloud. And it makes sense, right? I mean, who would you trust more to kind of secure environments. Your kind of two-person security team that you don't pay really well, or maybe AWS who has hundreds and hundreds of security experts. You know, the cloud providers, they just have the resources to put at this kind of stuff. Addressing patches, addressing vulnerabilities, again, they're going to do this way quicker than you are. In terms of physical security and data centers, again, their data centers are way more secure than, you know, the servers that you put in the closet down the hall. So I think at least this is the kind of story I've been pushing for a long time and talking to people about. The cloud is a much more secure environment to run your workloads, to put your data, until it isn't. And there's been a lot more incidents, more and more on the major cloud providers, where they've just had security incidents or breaches. This is a very recent one from Microsoft, where Azure just had a huge data breach. Amazon is almost famous for its challenges around the configuration of its services. So S3 is kind of the most obvious one, where people misconfigure it and it leads to a data breach, but there are others. And you can kind of say, maybe that's not AWS's fault. It's a configuration issue, but if enough of your users have the same problem, I think that kind of becomes your problem. And not to leave Google off the hook, but this was a really big one they had last year, or actually it was a vulnerability in GCP that, again, led to a lot of companies' data getting leaked and getting out. So this is, again, something that's happening more and more, and got to witness an event like this fairly recently with a client. They reached out because they had been subject to a phishing attack. And this was from a Play ransomware group, fairly standard phishing, where somebody got an email, clicked on something they shouldn't have, already not a good thing. It got compounded by the fact that the account which clicked on it was an administrative account, and also they had absolutely no two-factor authentication set up. So from that point, it was very easy to get access. They essentially encrypted all of this company's data and demanded ridiculous ransom. Don't want to mention the name of the company, but maybe they didn't have the best practices in place, but I've seen much worse out of a lot of different companies. So they kind of came to us and they were like, this is a situation, we need to rebuild everything from scratch. And we're like, okay, you know, at least, you know, they have backups, this is a good thing. But this is what the cloud is made for, right? Being able to restore, being able to recover from these things. So they had backups, but unfortunately they had no automation in place to set things up. They had, unsurprisingly, very poor documentation. The people who had set this stuff up originally were not even at the company. So what could have potentially been maybe a couple hours of downtime in an ideal state where you can come back up, resulted in weeks of trying to just uncover where things were, how things were set up, and getting them back up and running, which ended up costing this company millions of dollars. And again, they kind of had this assumption that, hey, we're in the cloud. The cloud is supposed to be a secure environment. So yes, they could have done things better. Yes, they didn't have best practices, but still it's this kind of narrative which we're told, which I as a consultant am partly responsible for, which turns out to not so much be the case. We don't get our on-demand resources. We don't get our on-demand resources. It's not secure, but at least it's cheap, right? The cloud is much cheaper place to run your workloads, to run your environments. And again, this one makes sense, right? It's economies of scale, okay? Instead of every company needing to have their own data centers, run their own servers, and have people to manage the infrastructure and leverage all that, we'll just pull it all together and it will be cheaper, right? This is the idea of cloud, of optimizing it and sharing resources among people. And on top of that, we just pay for what we use, right? That's the idea of, I need stuff now, I can spin it up. When I'm not using it, I can spin it down. You can't do that if you're paying for the servers full time. So again, the cloud is a cheaper place to run your resources. Just out of curiosity, how many people here at your companies have an initiative to try and reduce cloud costs? Cool. Everybody who doesn't have their hand up is a liar. Fair enough. So again, I speak to lots of companies all the time. It's my job, what I do, and every single one of them, this is their top priority. Their cloud spend is out of control. They've got big pressure to cut their budgets. Most of them don't even know where they're spending it. They've got no visibility. They just kind of opened up access, and people are running things way over budget. So, what kind of happened here? I think the idea is that, yeah, sure, on a case-by-case basis, maybe if I'm running a VM in the cloud versus on-premise, yeah, that's cheaper. But the reality is that because it's become so easy and so accessible, is that we're running way too much. We're over-provisioning in terms of our environments. There was a study recently looked at Kubernetes clusters. It's like, I think on average, they're like threefold bigger than they need to be in terms of the resources that are allocated. Just because it becomes easy to use, feels like it's cheap, we just run way too much. And the result is the costs are just out of control. There's even starting to be the question, coming back to this idea of repatriation, of maybe it's not even that cheap to begin with. So around the talk of repatriation, somebody who has gone through this journey very publicly, DHH did something, made Ruby, also he's a dickhead a bit, but he was very public in their leaving the cloud, and very transparent as well. So he kind of showed the numbers, their calculations, and what he concluded is that they were going to save $7 million to run on-prem. And I think if you look at his calculations, I think there's definitely some factors he didn't consider, but not to the tune of $7 million, right? So this kind of begs the question of, is it really cheaper to run our resources in the cloud or not? And an example, I was working with a company that I'm working with today. We kind of go in, and of course, one of the things, we need to reduce our cloud costs. So you kind of look at the obvious signs. What are they doing? And their non-production was like 20x the cost of production environments, and they were running them 24/7. So easy, just shut those things down overnight on the weekends. But they couldn't, because in order to bring those environments up, it just took them days to get the data in. They had to get the snapshots from production to get the specific data. They had to get that cleaned up. They had to get everything properly configured so that they could be used. And that just took days, so they didn't have the means to just shut things down when they didn't need them. And again, yes, if they had ideal processes, if everything was fully automated, this could be achieved. But again, this is kind of the goal that we've been sold. But if you don't have everything perfect, then it turns out the cloud is not actually cheaper. And the last one I want to touch on is this idea that the cloud is green, is a sustainable solution. And again, there is some logic in this, right? A little bit similar to the cost idea of that we're optimizing our resources, right? If we're running our own servers, our own data centers, we're not going to be very efficient in terms of our usage, because we have to over-provision because it takes so long to get a new server in. So again, if we're sharing resources amongst everybody, then they're going to be much more efficient. There's going to be less energy usage, less carbon imprint. And again, if we look at the data centers as well, who is going to be more efficient in terms of energy usage? Is it going to be a small company, or is it going to be the Googles, the Amazons, the Microsofts? They're very much incentivized to reduce energy, not because they're great people and want to save the environment, but because that's cheaper for them. So they're generally very efficient in terms of how they run their data centers. But the not so secret of the cloud is that it's actually a huge impact in terms of carbon footprint. It is one of the biggest sectors of carbon emissions. And again, on a quick comparison scale, yes, it's more efficient. There's less carbon imprint if you're running a workload in the cloud versus on-premise. But again, it comes back to this idea that because it's easy, because it's seemingly cheap, we just overuse. And it's just growing and growing. And if you just look at kind of what's coming in terms of AI, the amount of resources that it needs, this is just going to continue to grow and grow quite out of control. So we can't get resources on demand. We can't be secure. It's not cheap. It's terrible for the environment. I guess, what do we do? We just kind of go back to running everything in server closets like cave people. It seems tempting, but I think that's probably not the thing that we do here. But I think it is a moment where we can kind of step back and maybe reevaluate the promises we were told, reevaluate our assumptions, right? This, when we all first got into the cloud and got really excited about it, maybe that was a little bit too much. And maybe this is something that we do often in tech. This is Gartner's tech hype lifecycle curve. You may have seen it before, but it kind of describes what we go through every time. And it can be on different time scales, right? And it's interesting to think of the cloud being something that's been around for a long time, that we're only just at this point. But I feel like this is where we are right now, right? We've got really excited for a long time, growing, a lot of new features, a lot of excitement. And what I've witnessed personally, at least in the past year or two, is a lot of this disillusionment and this frustration and the problems that we're seeing. So I guess the good news is that, we're coming up the slope of enlightenment and reaching more of a equilibrium in terms of what this really means for the future. But I think we need to, again, also take a look at what are the lessons that we can learn out of this. And if I look at the examples I talked to before, right? So in Som's AI case, their challenge around GPUs. Well, what we can do to try to solve that is build abstractions. So we build an abstraction where their model training runs, their inferencing runs, in the end shouldn't care about where the GPUs are. So we build an abstraction where whether those GPUs are on Azure, are on GCP, AWS, or any of the smaller providers, or somebody's GPUs in the closet, they shouldn't care, and we can abstract that away from them to provide that flexibility. Potentially even not GPUs, even TPUs, or any other technology that comes in the future. So this idea that change is going to come, and you need to prepare for it. So it's kind of the concept of evolutionary architecture. And the second one is kind of important, and I think we repeat a lot, but this idea that technology isn't something that's going to just save you, right? You can't buy a product and it's just going to fix things. We can't just migrate to Kubernetes and then all problems are fixed. But it's a trap we continue to fall into. So again, the example of a company who kind of assumed they were secure because they're in the cloud, obviously this is false. But even, okay, maybe we'll go and we'll pay a lot for a high-tech cloud security product. That's still not going to solve it, right? You have to actually do the hard work. You have to change your processes. You have to be smart and evaluate what actually it is that you're working towards. What are you going to measure, and not just rely on a simple technology solution. And the last one here, I kind of hate this term, but this idea of being cloud smart instead of cloud first. Again, in the past, like 10 years, it was a lot of this kind of blind running to the cloud, right? We're just going to get into the public cloud, open wallets, the future would be better. And obviously that probably wasn't a good strategy. So the idea that looking on a workload basis, does it make sense for this to run in public cloud? Or maybe this workload specifically is better on premise, or maybe it needs to run on the edge. But just being a little bit more intentional about what is the strategy and what makes sense, and what is better. Right? Do you need something that's going to be more efficient? Do you need something cheaper? And being more intentional about the decisions. I think the biggest one also is this idea that the idea of constraints breeds creativity, right? And the cloud has kind of been like this free reign, unlimited computer, unlimited resources, unlimited possibilities, which has been great. But I think if we actually bring the constraints back, we can come up with better solutions. And again, I think back to my first job where we had very strong constraints technologically. I saw people come up with really creative and efficient solutions. And I'm not sure how many people have followed the drama with Voyager in the past few months. So Voyager is a satellite which was launched in 1977, I think. So obviously very, very old technology. It has explored the solar system. It is out of the solar system. It's still exploring the universe, still sending back data. And they ran into a problem in November, I think, where the data was just coming back. They just couldn't read it. It didn't make any sense. He's like, cool, how do we debug this? Like, have you ever debugged a Kubernetes cluster, but it's in like the Asia Pacific region, so you get like an extra, like 100 milliseconds of lag time? Like that's a pain in the ass. So imagine you've got 45 hours return time between when you're running your kubectl commands and you get a response. That's what debugging Voyager is like. 45 hours return trip. But the team was able to discover there was a certain chip which just stopped functioning. And when it's a hardware issue, perfect. Throw it away. We'll launch a new one. Again, not very easy to do on a satellite that's outside of the solar system. But they found a solution where they would move that memory to other parts of the chips, and through these 45-hour debug cycles, were able to shift everything so that the memory would go to functioning chips. And after a couple of months, just last month, they were able to get actual data back from Voyager again. So they were able to fix this problem with very, very strong constraints. And I think that's kind of the lesson that I want us to take away, is that the cloud still has amazing possibilities, but we need to bring the limits back and really define those. And whether that's just financial budgets in terms of what's allowed for this project, in terms of just having strict SLAs, maybe it's carbon emissions that we're going to limit on. But if we bring these back, then I think we can build much more efficient solutions. We can build much more performant, much more secure, much more environmentally friendly if we stop to think of this as an unlimited supply of resources, but actually bring those constraints back in. And with that, I apologize for the pretentious quote from Marcus Aurelius, but I think that fits in nicely. Thank you very much. Sure. Yes. Does anybody have questions? I love questions.
Hi, great talk, and definitely the cloud is broken. A lot of challenges you mentioned. When I speak to customers, one of the biggest challenges they are is like, okay, we are frustrated with AWS, we are frustrated with this cloud, but the problem is you can't really move away from it because of the vendor lock-in, like egress fees and all these other practices that the hyperscalers follow. And because there are other providers out there who are working on these challenges, like reduce costs, green initiatives, more secure, but they can't move away from hyperscalers because of being trapped in vendor lock-in. What would you recommend them to do? I don't think so. Thank you. Great.
Thanks. Really good question. And I think vendor lock-in is something that which is, it's kind of thrown out in both directions, right? Of, oh, well, we're locked in now, we're stuck, or we don't want to be vendor locked in, so we're going to do this. And it's just, we need to put data to that, right? And I think we can, in terms of, okay, how much time would it take us to move away from AWS or for any technology? And then what is the benefit that we think we get out of it? And then you can make it more of a data decision of whether you're vendor locked in or not. What I'm seeing more often is folks that are on the other side of like, well, we're going to be on, we want to be on multiple clouds, so we're not vendor locked in. And I feel like that is often a worse decision. And again, because there's no data behind it, if you look at how much you're actually going to pay to like run a full backup on GCP where you're running AWS, and maintaining that and maintaining the expertise and everything else is huge. And similarly, if you're trying to build a solution which is not vendor locked in, so again, Kubernetes was kind of built for this. Like it's become the universal API of the cloud, which is great. So that provides a certain kind of abstraction. But if you're not using any of the managed services from clouds, it kind of becomes a point of, you know, are you even leveraging the benefits of cloud? So I think it needs to be more of a data-driven conversation, a data-driven decision in terms of vendor lock-in, and looking at, again, what is the effort it would take to us to move away? What is the effort, what is the benefit that we think we get from leveraging cloud or leveraging managed services, and then make that decision that way. The other thing I would say is that if you're already locked in and want to move away, you want to be able to do that in a piecemeal fashion. And again, looking at, okay, per workload, does it make sense to run this in another cloud or on premise, and not just as like as a whole? And again, that's easy to say, but if you don't, it requires a bit of work up front of like actually having a modular architecture where you can pull things out. So often there's a bunch of upfront work to get there, but I think that work is beneficial regardless to have more of a evolutionary architecture where you can change a specific technology or move a certain piece somewhere else. So I think that's the general direction that organizations, platforms need to go, because then you're just, you've got a lot more freedom of choice. That was a very rambling answer. I hope I answered your question.
Can we get, there we go. Okay, I'm gonna stop yelling.
I just wanted to add one point, because you mentioned egress fees, that all the three of the major clouds have all put out agreements that if you are exiting their cloud to go to another cloud or to go on-prem and you are pulling all of your data out of the cloud, they will waive those egress fees, and there are pages for each of those. So I think GCP did it in January, AWS just did it a couple months ago, and then Azure followed. So just one less constraint exiting the cloud, but you made a good point about if you're going to be going multi-cloud, then that becomes more difficult to do. Just wanted to bring that up.
Yeah, that's a good point, and that's a good, yeah, I guess direction we're going of trying to make it easier for folks to move.